Okay, in today's lesson, we're going to be talking about graphing relationships. So before we get into taking a look at any graphs or any scenarios, let's talk about some vocabulary that we're going to need in order to successfully talk about these items in graphs. So the first one is behavior. We can have three main types of behavior in a graph. We could have an increasing graph, which means as we read from left to right, as the x value is increasing, so is the y. This is going to look like a positively sloped graph. So something maybe that looks like that. A decreasing behavior means as x gets large, the y value gets small. So it's decreasing in nature. It's a negative sloped graph, which I'll draw a sketch of a negative sloped graph. And then the third type is a constant graph, which means as we read from left to right, as the x value is increasing, the y value is remaining the same. So a constant graph is just going to look like a flat horizontal line. Now, we can have a mixture of these three types of behavior in all one graph, which we're definitely going to look at today during the examples. The minimum is referring to the smallest y value, whereas the maximum is the largest y value. The domain are the x values that are being utilized by the graph, and then the range are the y values being utilized by the graph. A discrete graph is countable numbers, meaning that we couldn't have values in between two whole numbers. And then a continuous graph, sorry, that's cut off at the bottom there. The continuous graph can take on decimal values, and so it's a measurable value. Okay, so one thing that we're going to have to do in this lesson is take a look at a graph and then develop a scenario that would fit that graph. So if we look at the axes, the x-axis is referring to time, and the y-axis is referring to temperature. So this is a time versus temperature graph. And as we look at the behavior of the graph, this one is an increasing behavior. So as time increases, the temperature does also. So if we think about what that could be, it could be you just turned on the oven and you're waiting for that oven to heat up. So as the time increases, the temperature of the oven is increasing. It could mean the temperature outside. So if we get up in the morning, as time increases, the sun comes out, the temperature also increases. Here's another graph that we want to take a look at. What is a scenario that might fit this graph? Notice that we have more than one behavior going on with this graph. But first, we want to take a look at what is the x value representing and what is the y value representing. So in this scenario, x is representing time and y is representing the distance from home. Okay, so maybe we're at school. And at first, we're going to leave school and get closer to home during this portion. So as time is increasing, our distance from home is decreasing. We're getting closer to home. So maybe at the end of the day, when we're leaving school, we're on the bus and we're getting closer to our bus stop. Here is where the bus does stop. So as time is continuing to increase, our distance from home is not changing. So maybe the bus made a stop and they're letting off students from the bus. Okay, and then our distance from home again starts to decrease. And then we are at our house. So maybe we're the second bus stop in the ride from the school to our house. Okay, guys, take out a sheet of paper and write a little story for this particular graph. It says the distance a delivery van is from the warehouse varies throughout the day. The graph shows the distance from the warehouse for a day from 8 a.m. to 5 p.m. Okay, so we want to identify the different segments of the graph, write a little story about what's going on with that delivery van during its trip during the day. Pause the video here and then unpause to get a possible response. Okay, hopefully you pause the video and you have your response there. I'm going to give you one scenario that could possibly fit this graph. During section 1, as time increases, distance is increasing. So the delivery van is leaving the warehouse and heading towards its first stop at a pretty high rate of speed. They have to slow down for some reason. So maybe they were on the highway and now they are slowing down to a stop sign at like an exit ramp or something. They sit at that exit ramp, that stop sign at the end of that exit ramp for a little bit. And then they continue to increase their distance from the warehouse during section 4 at a pretty high rate of speed. Okay, they come to a stop during section 5, so maybe they're making a delivery here. And this delivery at section 5 would be at the maximum of the graph. So it is the largest distance the delivery van goes during the day away from the warehouse. It's the largest distance from the warehouse that the van travels. Okay, as they start to move again, they are decreasing their distance to the warehouse. So they're on their way back to the warehouse at a moderate rate of speed. Maybe they hit another stoplight at section 7. They come to a stop for some reason. Maybe they're making another delivery that's closer to the warehouse than this stop was at number 5. Number 8, they are again decreasing their distance from the warehouse. So they're heading back to the warehouse. Their speed is kind of slow there. So maybe they're in a residential area. And then during the last section of the graph, they are traveling at a higher rate of speed, but getting closer to the warehouse. So they're returning to the warehouse, maybe on the highway during section 9. Okay, there's lots of different explanations that could fit that scenario, but guys, we do want to be paying close attention to the behavior of the graph. So is it increasing? Is it decreasing? Is it constant? And making sure that our scenario matches those behaviors. Okay, for this next example, we have 3 different graphs, and we're trying to match them with 3 different hoses that are explained at the top here. 3 hoses fill 3 different water barrels. A green hose fills a water barrel at a constant rate. A black hose is slowly open when filling the barrel. A blue hose is completely open at the beginning and then slowly closed. The 3 graphs of the situations are shown. Okay, so first of all, the first hose that was explained said a green hose fills a water barrel at a constant rate. So if we look, this is slow filling at first. It's increasing at a slow speed because the slope isn't very steep there. And then it gets much steeper. The slope increases towards the end. So that's not a constant rate. That's a changing rate. If we take a look at graph B, as time increases, the water in gallons is also increasing, and the slope is constant. It means that it's increasing the same amount per unit of time. So B would be our green hose. Okay, the next hose that's explained, it says a black hose is slowly opened when filling the barrel. So if you're turning on the hose just a little bit at first, and then you increase the water flow, that's going to be graph A. So graph A is going to be our black hose. And then the last one, the blue hose, is completely open. So that's going to be a lot of water rushing in and then slowly closed. So we see that the rate of water level is increasing very fast at first and then trails off. The speed decreases as we, slowly turn that hose off. Okay, so I guess our colors, guys, for A, it was black. For B, it was green. And for C, it was blue. All right, this next example is a you try. So read through that scenario at the top and again, try to match the balls with the appropriate graphs A, B, or C. Pause the video here, see what you can come up with, and then unpause the video to get the results. Okay, hopefully you took some time to pause the video. Unpause the video here and let's talk about the results. You and your friend are playing catch. You throw 3 different balls to your friend. You throw the first ball in an arc and your friend catches it. Okay, so taking a look at our 3 graphs, our friend is not going to be at a height of 0. Okay, here in B, we see that this ball stops at a height that's above the ground. So that could be possible. This one, we do throw the ball, but it doesn't have that arch like it was saying. So I'm going to say graph B best matches ball number 1. Okay, the next one says you throw the second ball in an arch, but this time the ball gets stuck in a tree. Okay, again, graph A, the ball looks like it's landing on the ground. So a tree is going to be at a taller height than 0. Okay, so I'm going to say that this is ball number 2. You throw the ball, you're arching the ball up, but then it gets stuck in the tree. Okay, and then you throw the third ball directly at your friend, but it lands in front of your friend and rolls the rest of the way on the ground. Okay, that is ball number 3 because again, we see that the ball is landing on the ground here and rolling the rest of the way. Okay, so now we're going to reverse the process, guys. We are going to have a situation and we have to come up with the graph for it. So this says sketchy graph of the situation. Determine whether it's discrete or continuous and state the domain and range used. Okay, so it says a student is taking a test. There are 10 problems on the test. For each problem the student answers correctly, the student received 10 points. Okay, so for number of problems correct, we could have anywhere from 0 problems correct all the way up to 10 problems correct on the quiz or the test. So 0 to 10. 5 is in the middle. 1, 2, 3, 4, and 6, 7, 8, 9. Okay, so I'm just counting by ones across that x-axis. And again, that's representing the number of problems correct. Now, it did say that each question was worth 10 points. So if we have 10 points per question and there's 10 questions, we could have up to 100 points available. So if I come up with a scale, I'm going to cut it in half there at 50, and I'm just going to count by 10. So 10, 20, 30, 40, and 60, 70, 80, 90. Those are supposed to be evenly spaced. I'm trying to do that with my finger on this touch screen, so it's a little difficult. Okay, guys, we would go ahead and mark a dot at if we got 0 questions correct, we'd get 0 points. And then our next value, if we get 1 question correct, we get 10 points. 2 questions would be 20 points. 3 questions, 30 points. So we would have dots in this straight line. Hopefully those are lining up correctly. And we'd have to determine, should we connect these points or not? So we'd have to ask ourselves, well, could we get values in between? It doesn't say that they're awarding any type of partial credit or anything like that. So I assume it is just, if you get one question, you automatically get 10 points, no partial credit. So this would be a discrete graph. I would not want to connect those points together. So it is discrete. And then domain, those were the x values. So our domain is going from 0 to 10. And our domain would include both 0 and 10. So if I write that in interval notation, that's my domain. And then the range, again, would be the y values used on the graph. And those range from 0 to 100, again, including both the 0 and the 100. Okay, so we have a discrete graph, and our domain is from 0 to 10 inclusive, and our range is from 0 to 100 inclusive. All right, our last example for notes today says, a bathtub is being filled with water. After 10 minutes, there are 75 quarts of water in the tub. Then someone accidentally pulls the drain plug while the water is still running, and the tub begins to empty. The tub loses 15 quarts in 5 minutes. And then someone plugs the drain, and the tub fills for 6 more minutes, gaining another 45 quarts of water. After a 15-minute bath, the person gets out and pulls the drain plug. It takes 11 minutes for the tub to drain. Okay, so taking a look, we have to come up with some scales for this graph. So let's first take a look at all the times that are mentioned. So first of all, we see that for the first 10 minutes, they're filling the tub. Then for 5 minutes, they accidentally pulled the plug. So there's 15 minutes. 6 more minutes, they're filling up the tub more. So that's a total of 21 minutes so far. They take a 15-minute bath. So that would be 36 minutes. And then it drains for 11 minutes. That is a total of 47 minutes that they are utilizing the bathtub. So I'm going to go ahead and count by tens from 0 to, let's round that 47 minutes to 50 minutes. Okay, so if I count by tens, actually I think I'm going to count by fives. So that way I can mark the middle. 25, so this would be 5, 10, 15, 20, 30, 35, 40, 45. Okay, so I'm counting by fives on the time, the x-axis for time. Okay, water. So I'm going to change color real quick. Let's locate anything that's dealing with water. So they fill it up 75 quarts of water. They lose 15 quarts, so that brings us down to 60 quarts. And then, let's see, they fill 45 more quarts of water. So let's see, we were at 60 plus 45, that's 105. Okay, and then they're going to let it drain out. So our maximum is 105. I'm going to actually go to 120 on my scale, and I'm going to count by 20. So again, I can mark the middle. So the middle's at 60, and this would be 20, 40, and 80, 100. Now keep in mind, I only go to 105 quarts, and my time only goes to 47 minutes. So when I make this graph, I want to try to make it seem like, again, I'm not quite reaching that maximum of 120. Okay, so let's go ahead and put some points on the graph. After 10 minutes, there are 75 quarts of water. So at the 10-minute mark, which I counted by fives on the bottom, so 10 minutes, I'm at 75 quarts of water. And guys, we have to think, should we connect those points? So the water's not just going to jump from 0 quarts to 75 quarts right away. It's going to increase slowly. It's going to hit all of those values in between 0 and 75. So I am going to connect these two. It's a continuous graph. Okay, then we accidentally pull the plug and it loses 15 quarts in 5 minutes. So at time 15, it's going to drop to 60 quarts. Okay, then we start filling it again and we put in an additional 45 quarts of water. That's going to get us to that maximum of 105. So 6 more minutes. Let's see. We were at 15 minutes. So that's going to be 21 minutes. We're at 105. So just over 20, we're at 105. Sorry, guys, those are supposed to be all connected. It's really hard to do that on a touch screen. Okay, then it says that they take a 15-minute bath. The water level is not going to change for those 15 minutes. So we're currently at 21 minutes plus 15 minutes. That's 36 minutes. We are still going to be at a water level of 105. Well, 105 quarts of water. Okay, then we pull the plug and we drain out the water. It takes 11 minutes. That's going to put us at that 47-minute mark. And the water level is going to be at 0 at that time. So hopefully that looks like 47 minutes there on the x-axis and not quite to that 50. And again, our maximum is at 105. Okay, so this is what our graph would look like for the bathtub scenario.